Good afternoon, everyone, and welcome to today's webinar, Proactive Water Management, Essentials for Program Verification and Validation. My name is Don Doherty with HESNI. I'm the administrator, and before we get started, we have a few brief announcements, and I want to begin by introducing one of our board members and president-elect of HESNI, Ryan Ollie. Ryan, do you have a few words?
Yes, thank you, Don, and welcome everyone to our event today. So just real quick, we're going to go through a few housekeeping items, and then we're going to pass it along to the Phigenics team and their guest speaker today for the program. So before we get started, we just want to let you guys know that next Wednesday, April 28th, we have our indoor race, or as it's known as the Half-Fast Cup, and it's going to be taking place at Accelerate Indoor Track in Mokena, Illinois. HESNI members, may join the race competition. There's going to be an axe throwing cage as well. There's some social events we have planned also, so please come out, relax with friends, and enjoy the fun food and refreshments. Also keep in mind that, we'll be complying with all local and state COVID-19 protocol. And so just, if you guys are able to make it out to this live event, we would appreciate it as well, and I'm sure you guys would too. Also, in the near future, on Saturday, May 8th, you're welcome to come with family members, friends, and participate in an outdoor wetland and park restoration project for a few hours that we're throwing at Big Marsh Park. This is located on Chicago's far south side, and it's part of the bigger Chicago River Day event, which is a community service activity hosted by Friends of the Chicago River. For this event, lunch will be provided afterwards, and we'll have some group activities and a lot of fun community service activity as well. So please feel free to join us for that event. And last but not least, Thursday and Friday, June 10th and 11th, we are hosting our annual conference live as well. That's going to be back at Northern Illinois University in Naperville. We took a year off last year, obviously, with the pandemic, but we're grateful that, we're able to host it again in person. And we're going to be featuring a keynote speaker that's going to be a surprise, and we'll announce that soon. And we'll have multiple education seminars over both days, exhibits, and plenty of time for networking and socializing. So we are excited to share with the membership that we will be having these three live events coming up. And again, we'll be complying with all the local and state protocol for COVID-19, but if you are able to join us, we welcome everyone. And then that is the housekeeping portion. And now, without further ado, I'm going to introduce our speakers. So today's presentation is Proactive Water Management, Essentials for Program Verification and Validation. We're joined by Emily Schrader and Brandt Moffatt from Phigenics, and we're also joined by their guests for the presentation, Steve Barstatis, who is the Director of Facilities at Ann and Robert H. Lurie Children's Hospital of Chicago. So without further ado, I will hand it over to you, Emily, and you can get started.
All right, thanks, Ryan. Appreciate the introduction. Hi, everyone. My name is Emily Schrader, and I'm with Phigenics. I'm really excited to have the opportunity to present to you all today. As Ryan mentioned, our second presenter is going to be Steve Barstatis. He'll be reviewing some slides later in the presentation. But our topic for today is proactive water management, the essentials for verification and validation. And so we're really going to be covering the fundamentals of water management today. So I hope you guys all find value in that. So I'd like to start briefly by clarifying what it is we do and what makes us a little bit different. So Phigenics chooses to be independent from the sale of water treatment products and services because it conflicts with our only bias, and that is to work with facility water management teams to achieve defensible, data-driven water management programs which verify and validate that their building water systems are safe, efficient, and cost-effective. So that's really our core purpose as a company, and that's how we help our clients. So I know Ryan introduced me, but I'll provide a little bit more background. I'm an account manager for Phigenics in the Chicago area, and I joined Phigenics 1 year ago in April of 2020. I have about 6 years experience in the water industry, and my educational background is in industrial engineering from the University of Illinois. For an overview of our learning objectives today, we're going to start by reviewing the hazard of Legionella and the factors that cause it to spread throughout a building water system. So really trying to understand what the public health problem is. We'll then examine the difference between verification and validation. So how to address this problem through industry guidance and a review of those primary components of a water management program. We'll finish up by examining how to efficiently monitor and confirm program effectiveness. And for this, we'll review 2 case studies from healthcare facilities. And so the review portion might be information a lot of you guys have seen or already know, but after the review, we're going to be reviewing, covering some topics that are critical for your water management surveys and overall defensibility. So if you have any questions throughout the presentation, feel free to put them in the Q&A function in Teams, and we'll certainly have time to answer those at the end. I expect this to take about 40 to 45 minutes. So starting with an overview of Legionella and other waterborne pathogens. So Legionella is a gram-negative aerobic bacteria, and it's ubiquitous. You can find it in the natural environment in lakes, streams, and soils. But Legionella really becomes a hazard when it's able to enter a building water system, amplify, and then can infect humans. And so for that to occur, there needs to be the right growth conditions and opportunities for aerosolization and exposure. I also wanted to address some other pathogens of concern that are outlined in the CMS memo. So CMS stands for Centers for Medicare and Medicaid Services, and they address the risk of Legionella and these other pathogens in a document called the CMS memo, which we'll review later in the presentation. And similar to Legionella, all of these pose a risk when able to amplify and infect humans from a building water system. And the good thing is that the strategies used in a comprehensive water management program for addressing Legionella are going to be very similar to addressing these pathogens. And so for the most part, if you're managing your water properly to control Legionella, often these pathogens will also be under control. So what causes these pathogens to amplify after entering a building? There are a lot of different internal and external factors, and on the screen show the primary internal factors to your facility. A big one is temperature, and that's because the ideal range for amplification is around 95 to 115 Fahrenheit, and that's where most domestic hot water systems operate. So that just puts an added risk to that system. Water age or any stagnation in the piping is another concern because it allows the disinfectants to break down or be consumed. Both scale deposits and biofilm can protect Legionella and other bacteria. And biofilm is especially concerning because it allows for the presence of higher life forms such as amoebas. And Legionella use amoeba to multiply within a water system. And then lastly, any pH or water pressure changes can also contribute to amplification. So we've learned about Legionella as a type of bacteria, and when allowed to infect humans, it causes Legionnaire's disease. So transmission occurs when water containing the bacteria Legionella is aerosolized or aspirated and breathed deep into the lungs. So the Legionella infects the lungs and impacts the location where oxygen transfer occurs. Symptoms are very similar to pneumonia, but Legionnaire's disease is typically much more severe and can cause long-term debilitating effects. So really everyone is at risk of contracting Legionnaire's disease, but those at the greatest risk are listed up on the screen and include immunosuppressed individuals, the elderly, current or former smokers, dialysis patients, and transplant patients. And this is why water management is so important in healthcare facilities, because this is where those highest risk populations can be found. So why is all this information so important? On the left, you can see the rising cases of Legionnaire's disease over the years. And this increase in cases is partially due to an increased awareness of the disease, which has led to additional clinical testing. But we know that, CDC investigations show most cases were preventable or could have been avoided with effective water management. So this just shows why we need to be proactive with water management programs to prevent this graph from continuing to rise. So we next wanted to share where Legionella is typically found in a building water system. And I think this is interesting because most people hear about Legionella from the large cooling tower outbreaks where a lot of people get sick at once. But the data shows that most cases are caused from the potable water system. And these are typically sporadic and spread out over many months. In addition to your potable water system and your cooling towers, some other water systems of concern are hot tubs and decorative fountains. So this slide reviews some goals that a water management program should address. The most critical are to improve safety and efficiency. And you can't really do one without the other because they impact each other. But some other areas that a water management program might address are optimizing the lifespan of your capital assets, optimizing the cost to treat your water, or around overall documentation. And so the puzzle piece graphic you see up on the screen is what Phigenics calls our 4-box approach. We believe that looking at all 4 of these areas creates a comprehensive water management program. And that is to address both water safety and water efficiency in the potable and utility water systems. So having this holistic approach and looking at all 4 of these areas is ultimately going to optimize your total cost of operations in the long run. So as I mentioned, water management programs should address both safety and efficiency. And this graphic represents finding a balance between these two such that the total cost of operations is optimized. These two metrics go hand in hand, and it's really up to the water management team or the facility management team to find that balance. So for example, if the team is focused too much on the water safety side, they might not be using water in the most efficient way. And on the other hand, if you're focusing too much on conserving water, you might be compromising your water safety. So it's really important to look at both of these metrics when approaching your water management program. So I'd next like to transition into a review of industry-leading guidances. So we've covered why there's a need for water management in the built environment. And I'd next like to review what industry guidance is available to help us meet those needs. So these 3 guidelines were all established in the last 6 years, starting with the ANSI/ASHRAE Standard 188 in 2015. Then came the CDC Toolkit in 2016. And then the CMS memo came out in 2017 and fully adopted both the ASHRAE standard and the CDC Toolkit. So ASHRAE, for those who are not familiar, stands for the American Society of Heating, Refrigerating, and Air Conditioning Engineers. They came out with their standard as there's a rising concern for the risk of legionellosis in building water systems. And then the CDC Toolkit really came out as a resource for building owners and facility managers to help implement the standard. So it's a little bit easier to read and understand, but it's important to note that both of these documents send the same message when it comes to water management, and they're very well aligned. And then the CMS memo is the document that requires those who receive funding from CMS to have a fully implemented ongoing water management program based on these two standards. So as we move forward, we'll be focusing on the ANSI ASHRAE Standard 188 and what it tells us about water management. So as I mentioned, ASHRAE standard originally came out in 2015, and then it was updated in 2018. And it's known as the Technical Consensus Best Practice Document regarding water management in the built environment. And so it provides a clear list of what components should be included in a water management program, shown in Figure 1 on the screen. And this came directly from the standard. And so the standard says that a water management program should have a program team. It should have a description of the water systems or flow diagrams. It should have an analysis of the building water systems. It should have control measures, monitoring and corrective actions, and confirmation, which they say should include both verification and validation. And then finally, documentation is a really important piece because without documentation, it's hard to prove anything was done. So this slide provides an overview of Phigenics' approach to water management program development, which was adapted from that Figure 1 in the ASHRAE standard. And you might notice a lot of similarities between the steps we just reviewed and this process here on the screen. And that's intentional because we want to make sure that our programs are well aligned with the industry best practice. And so I'll go through each one of these steps and provide a little more detail on what that looks like within your water management program. So step 1 is forming a team. And your water management program team should be cross-functional, dynamic, should have the authority to make decisions regarding the water management program. And so you might notice this figure is a little bit bigger than the other steps. That's because it's probably the most important step of the process, because without a strong water management team, it's going to be really difficult to get through the next 6 steps. Step 2 is developing goals to measure the success of your program. Step 3 is describing the water systems. And this is where a detailed survey is performed to understand how water is used throughout the facility. So from this facility survey, what we typically make is what we call a process flow diagram, which is a simple line diagram showing where water is sent throughout the facility. And then we also make a written description of the water use. So we have a full understanding of how water is used in the facility. And then we move to step 4, which is analyze the water systems for safety and efficiency. And this step can also be referred to as the risk assessment or the hazard analysis. And so once we understand how water is used throughout the facility, we analyze each one of those processing steps for physical, chemical, and biological hazards to understand where we need to apply control to make sure that the systems are safe. From there, we move to step 5, and this is where a lot of your important program information is held. So we specify those control locations, we set control limits for each of those locations, monitoring and corrective action plans. And then as we move into steps 6 and 7, which is verification and validation, it really encompasses that confirmation step that we reviewed in the ASHRAE standard. And these 2 steps are really more part of the ongoing implementation of the program. And so as we move forward over the next few slides, I really want to focus in on this step 5 to clearly define what these terms mean and what that looks like in your program. So starting with control locations. So a control location is a point at which control must be applied to achieve the desired outcome. So from a safety standpoint, that might be controlling the hazard, or from an efficiency standpoint, realizing those efficiency gains. And so some examples of control locations could include the location at which your disinfectant is added, or the location in which you perform routine flushing throughout your facility. And from a utility side, it could be that location at which your cooling tower treatment is applied. And so it's important to note here that your program should not have a ton of control locations. So most programs will have around 5 to 8 control locations. And if they're not well defined, or if your program is overwhelmed with 20, 30 control locations, it's really going to impact the feasibility to implement your program. So next we'll review control limits. So at each of those control locations, there needs to be control limits, which are a maximum, minimum, or range of values for that applied control measure. And so control limits must be quantitative, measurable. They can be either a physical or chemical parameter, and they must be monitored and maintained. So an example of what a control limit might be. So if one of your controls is the disinfectant or the free residual oxidant concentration in the water, a team might set a control limit of 0.5 to 1.0 ppm as free chlorine, meaning that they need to maintain that disinfectant level within those control limits to make sure that the water is safe. So what happens when you don't meet those control limits? That's where a corrective action comes into play. So corrective action is a predetermined action taken to return those control values within the established limits when your monitoring shows that those limits were not met. And so a really important aspect of corrective actions is that they're documented. Because if your monitoring shows that your control limits weren't met, you need something to show, something was done to return those back into range. And so these are determined in that step 5 of the development process. So they're already written out and predetermined. So I also wanted to clarify, because I know some of these terms can be mixed up and can be a little confusing, but corrective action is not the action that's taken in response to bacterial results. So corrective action is specific to control limits not being met. So circling back to this process to steps 6 and 7, which is verification and validation. And as I mentioned, these 2 steps are really part of the ongoing implementation of your water management program. With you all being from healthcare facilities, I'm sure you all have water management programs developed. But what I would really like to emphasize today is to not just have a water management program that sits on the shelf. You really need to work it through with verification and validation. Both of these build really strong water management programs and defensibility. And if you're not verifying and validating your program, it's going to open you up to survey and defensibility issues. So as we move forward, we'll look to clearly define these 2 terms and understand what that looks like within your program. So starting with the definitions, for this we look directly to the ASHRAE standard. So starting with verification, ASHRAE defines verification as the initial and ongoing confirmation that the program is being implemented as designed. And so kind of put in some different wording that might be a little easier to understand. Verification is the confirmation that the hazard control activities are being performed and documented. And then validation is that initial and ongoing confirmation that the program, when implemented as designed, effectively controls the hazardous conditions throughout the building water systems. And so put very simply, what these 2 terms mean are verification, am I doing what I said I was going to do? And validation, is it working? So next, to provide a little bit more information on how you verify your program. The key here is the documentation. So if it wasn't documented, it's as if it wasn't done. And so the primary things you need to confirm are, one, are your control limits being met at those control locations? When those control limits were not met, then was a corrective action performed to restore those control limits? And were all of your operational and maintenance activities being carried out? So I also wanted to note that independent verification is the most effective and defensible way to verify your program versus someone within the organization or a voting member on the water management team. So we'll next review a couple methods of validation. So there's really two main methods to validate your program. The first is what we call clinical surveillance. And this is the process of actively testing patients with symptoms for Legionnaire's disease. The downside of clinical validation is that it's very reactive. So it really takes someone getting sick in order to take action or make any changes. So a more proactive approach to validation is through environmental water sampling. So I'll review kind of two different methods for environmental sampling. The first and the most common is through microbial culture tests. And this is either done through a spread plate method or a dip slide taken in the field. But a different method, which is a little bit more innovative and being used in the industry more often, is called molecular PCR testing. And this test provides a rapid result on the detection of Legionella DNA. So if you're validating your water management program, the program should really have a defined validation response, or the actions you take when the test results come back positive and show that the program is not effective. So this is typically represented through what we call a validation response guide. And an example is shown up on the screen. And so the purpose of this is to provide the team an algorithm to follow for remediation of those positives and next steps if needed. And this is typically, this isn't a core document of the water management program, but it supports the validation step. Okay, so next we're going to be moving into two case studies showing how water management can provide both safety and efficiency improvements in real-life healthcare settings. So for this first case study, Steve Barstatis will be presenting from his facility, Lurie Children's Hospital. So I'll turn it over to you, Steve.
Thank you, Emily. Emily, if you could just move to the next slide. All right, so good afternoon, everybody. And again, thank you for having me today. I'm Steve Barstatis, and I am the Director for Facility Services for the Ann and Robert H. Lurie Children's Hospital in downtown Chicago, as well as our Children's Hospital Chicago Medical Center with facilities throughout Northeast Illinois. Next slide. I'm here today to review our water management program that we have at one of our outpatient ambulatory surgery centers. This is located in Northbrook, Illinois. This is a suburb just north of Chicago. This is about a 26,400 square foot facility. This facility provides both intermediate care and is a surgery center for our Chicago, northern, and northwest suburban patients. The facility was originally an existing core and shell structure located adjacent to our operating Lurie Children's Medical Office building. It was built out in 2017 and 2018 and was opened in the fall of 2018. During our construction water management and validation testing, we really struggled to achieve negative Legionella and total heterotrophic aerobic bacteria, or THAB, test results. This was probably due to maybe the vendors or the contractors not following their plan. But what we ended up doing is we determined through a risk assessment, which considered the building layout, the use of the building, along with the construction water quality problems that we had, that a water management program would be built for this facility, which included assembling an independent water management team for this facility to oversee the program. Next slide. Through free chlorine residual testing, it was determined early on that the entering domestic cold water contained about 0.5 to 0.7 parts per million of free chlorine. This is normally sufficient for disinfection, and therefore building supplemental disinfection wasn't warranted for this facility. We set up a regular manual fixture flushing program in the building to increase the water quality and reduce Legionella and bacterial counts to acceptable levels. Over a period of months, we reviewed the testing and looked for patterns. This type of flushing was primarily somebody going around and flushing the actual sink fixtures, shower fixtures, etc. Frankly, we struggled through the first 12 to 18 months of the program. This was to get the water quality to the level which we expected. We have other water quality programs at our other facilities, and we know that what we can achieve. We had a breakthrough in the spring of 2020 when, in consultation with Phigenics, we decided to flush the domestic hot water return. This is at the point where it connects to the domestic water heaters. Once we started flushing, we saw a large increase in the free chlorine levels throughout the building hot water system. This improvement led to reduced positive cultures for both Legionella and THAB, and a subsequent increase in water quality for both the hot and the cold water at the fixtures. This is due to cross-contamination, which occurs because in our fixtures, the hot and the cold water flow through the same outlet point. Once we confirmed the success over several quarters of testing, we then automated the flushing by installing a solenoid valve and connecting it to our building automation system. This allowed us to flush automatically at a prescribed time duration. So we do it on a time duration at this point that was set by our previous manual flushing and chlorine residual testing. Again, we did some manual flushing, we had some success, and then basically automated it to reduce our manpower that was required to do that flushing at the hot water return. Next slide. All right, this graph that you're looking at right here, this is the displays the breakthrough. So you can see, and this is, if you look at it, that our free chlorine residual parts per million free chlorine on the left, we were down at that 0.05 level, maybe 0.07, but definitely not greater than 0.1. And what we ended up doing is right around May 7th or probably June, early June, we started flushing the domestic hot water return. And you can see that in doing that, our free chlorine residual in the return water, and therefore the whole system, the hot water system, increased to a level that was above 0.2. Our goal was to get above 0.2 because we know that 0.2 is generally a level that we've had success with having that disinfection level and in eradicating any type of bacteria or biologicals. So while a simple graph, this represents a significant accomplishment in our program. Next slide. All right, and here's the results of that. As Emily talked about the validation results, so we were taking actual bacteriological testing of the water at different fixtures. So you can see right there that back in 2019, we were looking at a 50% case where 50% of our tests came up positive for Legionella. And then right around the second quarter of 2020, when we decided we were going to start flushing the domestic hot water return, we ended up having 0 positive Legionella tests. So we later automated the flushing in the fourth quarter of 2020, and the process continues today. And you can see that Q2, Q4 of 2020, and we just did our recent testing in the second quarter of 2021, and we continue to have that negative Legionella testing. So again, the automated has really made a big help in this program, so that way we don't have to worry about if somebody's on vacation or something changed. We were able to continue that, and we really attribute these results to that effort. Next slide. All right, so I want to leave you with a few key takeaways from this particular case study. A comprehensive water management program is needed to make data-driven decisions. The program should really include a multidisciplinary team. I can't stress that enough. Emily mentioned that earlier. We include, by multidisciplinary, we include members of our facilities department, myself, some of my managers, our environmental services department. This is the department that cleans and maintains the facilities, and the clinical staff. This is some of the nursing staff, some of the other technicians, and finally the infection control department. These are really, it's really important to have different viewpoints in here because different groups look at things a little differently. Key takeaway number 2, if validation shows the program is not effective, adjust the program approach. Basically, be prepared to adjust because you're going to learn some things and understand the systems more. And I would just say I don't think we've ever had a program that we came out of the box with that worked right out of the box. We always had to make adjustments, some very subtle though. So key takeaway number 3, applying control and verifying disinfectant levels at the source is an efficient and effective method to control the hazard. This is very important, as the measurement of the disinfection levels we found to be critical in determining where the potential issues lie, and will definitely help you to plot a path towards better water quality. Next slide. Key takeaway number 4, validation should be the final step. Testing before having a program makes decision-making difficult. I will be the first to admit that we certainly started in a couple cases, not in this particular one. Before we had a water management program, we just started doing some spot testing. We found this to be a lot of wasted time. There was a lot of trial and error and figuring things out on the fly that really could have been avoided if we had developed the program first. And finally, point number 5, construction presents a risk to the water system before the building is opened. I can't really stress this any higher. In our experience, construction is in most cases our greatest risk to water quality. We mitigate this risk by getting ahead of it by integrating water management processes into the construction programs, as we did here for the Lurie Children's Northbrook ASTC project. So hopefully those key takeaways will give you a little more insight into this case and hopefully help you in the future. So thank you again for your time, and I hope this helps to give you some perspective by presenting an actual case.
Great, thanks, Steve. Appreciate that. To wrap up our presentation, I'll be sharing a second case study of an example of improved potable water efficiency through water management. And so for this example, this is from an East Coast hospital system. And the problem that they were faced with is that their control limits were not being achieved. And they were always asking the question, well, how much and how often should flushing occur? This is a really common question we see throughout facilities because it's not a set number and it's always changing based on, impacts on those disinfectant levels. And so some of those impacts, especially within a hot loop, might include, fluctuating levels coming from the municipality. Water use fluctuations is a big one. Maybe a facility uses more water on a weekday versus the weekend. And then biological demand will consume the disinfectants at different rates throughout the system. So our objective for this project was to really automate the flushing activities to optimize our control and verify that those disinfectant control limits were being achieved. So this graph shows kind of the before situation. You can see that the team decided to set a control limit of 0.5 ppm as a minimum. And the blue line you see at the bottom of the chart represents the daily free chlorine averages. So you can see that it varies anywhere between 0.1 to 0.3. And if we look at our maximum value, it seems sometimes those instantaneous readings were up near 0.59, and maybe at times they were achieving that control limit. But overall, the limit was not being maintained consistently. And so as a solution, the team implemented a water age monitoring program. And this graph kind of shows the result of that. And so what that solution included is a continuous chlorine monitor with a set point and a relay tied to an automated solenoid valve. So basically, if through the continuous monitoring, if the levels were below the control limit, that solenoid would open, it would flush water from that source and bring in fresh chlorinated water. And then once that control limit was achieved, that solenoid valve would close. And so another really important aspect of the continuous monitoring is that we have this time-stamped verification data to show that the program is being implemented as designed, or the program was meeting those control limits. You can see as a result, we have a tight control over with the daily averages, and it was consistently maintained at that 0.5 control limit. So through this solution, the team was really able to gain control over all of those outside influences on the disinfectant. And as discussed, validation is that final step to show that what you're doing is working. And so this chart shows % positive Legionella tests to support the success of the program. You see a downward trend, and after we saw that our control limits were being consistently met, there were 0 positive detections for Legionella. And so part of this project from an efficiency standpoint was understanding how much water it took to achieve that balance between safety and efficiency. And so we were able to quantify this with a water meter that sent our data to the web. And so for this specific hot loop, it took an average of 159 gallons per day to maintain that disinfectant level. And so one thing that's really important to note is that this is not a straight line graph. You can see that, some days we only needed to flush 50 gallons, and at other days we need to flush 300 gallons. And that difference is due to all those different impacts on the disinfectant levels in a hot water loop. And so really gaining control over these, you're never going to overflush or underflush. And having the data visibility really allowed us to quantify that from an efficiency standpoint. And so to wrap up with some key takeaways from this case study, number one is to understand the control. So really, you need to understand first how the disinfectant levels are impacted with flushing and if that control can be achieved. So once you really understand that, then you can optimize. We know you can optimize by putting a science to the flushing with disinfectant-based control. We know that automating the source water flushing can result in optimized water use, energy use, and manpower. And then that continuous monitoring piece really allows for your hazard control verification, or that critical data to support the water management program. So that really concludes all of the information I had to share with you guys today. At this time, I can take any questions that popped up throughout the presentation. And I also put my contact information up there. If you have a more site-specific question, feel free to reach out and I'd be happy to discuss it with you. But I appreciate the opportunity, and I really hope you guys learned something new or got something from this presentation.
Okay, thank you. Emily, at this time, I don't see any questions up on the Q&A screen. I hope that isn't because it's not working or not visible. So if any of you do have something you'd like to ask, please use that now, and don't forget to hit the send button when you do so. And having said that, I want to thank all three presenters today, Emily and Steve from Lurie Children's Hospital, and Brandt Moffatt, also from Phigenics, for joining us today. The presentation was very good. We really appreciate your time and all the effort that went into this. It's a very key topic, important topic to everyone in healthcare facility management, and we appreciate the information you were able to present today. Also, I want to thank all you folks out there, the attendees who can't speak, but we can see you or hear. We know you're here. Thank you very much for your time. We hope you got something out of today's presentation. And as usual, we will have a full video of the presentation available for viewing off of our website at www.hesni.org in the next day or two. If you need a CEU certificate, we'll have a link for that. You're able to download it, and assuming or presuming we're able to share these AV slides with you today, we will have a link to download that also. Anybody else have anything to add?
John, I think we have a question out there on the Q&A. Says, is there any talk about governing bodies putting pressure on construction companies about having a water management program during construction? Emily, do you want to take that?
Yeah, that's a good question, and I can add some, and Brandt, if you have anything to add after that. You know, right now there's no standard in place to, you know, to require that. I know the ASHRAE standard does mention the risks associated with construction or a new building expansion. So that the ASHRAE standard recognizes that risk, but we really see that fall on the building owner or, you know, the organization versus that construction company. And what we see is a lot of companies will create a, you know, a construction policy with water management included in it. And so that way the construction contractors have a clear guidance on what activities need to take place during that construction and during the commissioning of a new building. I don't know if that answered your question, Brandt, if there's anything to add.
Yeah, well, definitely there's a section at the end of ASHRAE Standard 188 that talks about what you should do, what the best practices are for a construction event and water quality. The CDC does state that over 30% of the issues concerning Legionnaire's outbreaks are due to a construction event or construction project. So it is important to, as Steve alluded to in his talk, to be on alert whenever you have a remodel or some type of construction going on.
So again, if I can add to Emily, from a facility standpoint, we recognized that a while back, and we actually implemented things into our construction specifications that, you know, we built in there, so that way the contractors knew that they had to do this. They included it in their pricing because there is a cost for some of this, and we implemented that. And we started early on 1 or 2 projects as some trial cases, and now we've actually got that type of activity built into all of our projects. And it just, we feel that it protects us. And in a project like the Northbrook facility or the Skokie facility or a couple of our facilities that we've worked on, it works out really well on a new facility, because basically that construction water management basically transfers right into the actual water management for the building once it's in occupancy.
So here's a couple of other ones. Don, you may have mentioned this. Can we get a copy of the presentation? I think we should be able to get that to Don. Is that right?
Yes, I'll have that. A copy, not a coopy.
Copy. And then another question, at what point in the return loop do you install a blowdown valve?
That's a good question.
I can take that if you want, Emily.
Yep, go for it, Steve.
Yeah, where we found out the best place to do that and where we install it on all of ours is we install it really close to or adjacent to where the water returns to the hot water heaters. So this is the single congregation point, basically, and forces the water, therefore, because of all the balancing valves in the domestic water system, to be pulled evenly through the system. And basically, we blow it down right there at the domestic water heaters, right before the hot water returns to the heaters. That's how we handle it.
Yeah, you said it perfectly, Steve. And I'll just add that at that return point, that's when we think about water age, that kind of has the oldest water age, right? Because it's gone out to the facility. So we typically see the lowest disinfectant there. So to remove that old water, to bring fresh water into the loop, that's the best location.
So here's another question. It says, when it comes to hot water control points in commercial buildings, is it more important for the supply temp to meet the control temp set point or the return loop to reach the control point?
Okay, I think I understand what that question is asking. So if you think of your control location as the heating step, so the hot water heat exchanger, then you have a set point for that. So let's say your set point is 130. And so maybe you make your control limits between 125 to 135. And so that's where, at that outlet of the heat exchanger, that's where you want to maintain those critical control limits. Now, based on what the temperature needs to be at the point of use, that's where you guys at the building design or the set points of the hot water heat exchangers are set, or the mixing valve to make sure that the temperature is maintained in the distribution or the return, like you mentioned. But really where you're monitoring is at that control location.
Well, I think that's all of the questions so far. And one comment, Emily, thanks for a great presentation. It's up there. So
All right.
you have at least one fan out there.
Well, thank you guys. I appreciate the opportunity.
Okay. Thank you all once again, and happy Earth Day to everyone. I think maybe somehow that occasion fits in with what we're talking about here. And do something nice for the planet. And if that's not enough, come and see us on May 8th for Chicago River Day. And by the way, the other activities that Ryan mentioned, you'll get more information and signups at our website at HESNI.org. Okay. If there's, well, there might be one more. No, another comment. Great job. Okay. All right. Thank you again, everyone. And again, have a wonderful day, the rest of your day and evening. I appreciate it. Take care.